Good morning, good afternoon, everybody. Thanks for joining. This is our second iteration of our series of the II 900 webinars. Hopefully everybody was able to join us last week as we talked about kind of the introduction to the II 900. We're going to go into a little bit more detail today. And if you stay tuned next week, we'll wrap up this little mini series with some more information. So again, thank you everybody for joining. Please ask questions at any time. Stay engaged with us. This is for you. We're doing this for you. So please learn as much as possible. If you have any questions, we will answer. And if we aren't able to provide the answer today, we will follow up. But I just want to introduce real quick Adam Sinclair and Justin Shear. For those who weren't here last week, they are going to be presenting today, and I'll go ahead and let them introduce themselves.
Right on. Thanks, Dustin. Appreciate that. My name is Adam Sinclair. I'm the Industrial Imaging Category Manager. So basically just in charge of the thermal imaging and acoustic imaging product lines at Fluke. I've spent quite a bit of time out in the field learning from customers and helping customers implement solutions. So excited to share some of that perspective and that learning with you today. And then Justin Sheard, I've asked him to just give me a hand in the presentation because he's got just a lot of deep application knowledge from his time both as an engineer and also in front of customers. So just wanting to give you a more well-rounded perspective of the technology and of the learning. So say good morning, Justin.
Sounds good. Thanks for the introduction.
Yeah. Here's what we're gonna spend our time talking about today. We're gonna start with an introduction to the technology. So what is acoustic imaging? I recognize that there's likely some of you on the line that either have an II 900 or an acoustic imager, or you've seen one in the past. So it may be a little bit redundant for you there, but also wanna just give a little bit of time for those that haven't seen the technology before to get up to speed on what it's capable of and some of the ways that people are using it. And then we'll talk a little bit about energy savings. So the title of this webinar is how this technology is being used for more than just energy savings. So we're not going to spend that much time talking about compressed air applications for energy savings, but I do want to set up that application and that value just so you can understand kind of how customers are using it in that space. But we're going to spend the bulk of our time in the other applications or the other ways that people have found or our customers have found and told us that they're using the product to add value in their facilities. And primarily it's around improving or maintaining product quality, keeping assets up and running for a couple of different reasons, which we'll get into, and then also the safety aspect. So the way that this technology allows people to inspect or troubleshoot from a distance has greatly increased safety at a number of facilities, and we'll share some of those applications and examples of value add with you. So that's where we're going. And like Dustin had mentioned, please ask questions. If there's a particular slide or topic that comes up that you want to learn more about or that you have some questions about, please put your questions in the chat box at the end. We'll have Dustin read through those and answer as many of those as we have time for in the call or follow up if we run out of time. All right, so to start, what is acoustic imaging? Acoustic imaging is really exactly what you see in those three pictures. Those are actual examples or images taken with the II 900, and what you see is a visible light image, or what you and I see with our eyes, or what you would see in a camera. And then in the middle or thereabouts in each of those pictures, you see what looks like a target. And what that is it's a representation of a sound in a given frequency range that was determined by the settings on the camera. So what you're seeing is compressed air leaks on a few different applications. So you've got like in the far left-hand corner, you've probably got a connection or an elbow that is leaking, and you've got sound coming out of that leak. So compressed air coming out of that void or out of that hole. And creating a sound or a leak that the acoustic imager is picking up on. In the middle picture, you've got an air hose or a drop down there, and you've got compression fittings, and you've got a bad connection there. Whether it's you need new hardware or you need to wrap it in Teflon tape or whatever the case may be, there is a leak that can be fixed and addressed there. And then on the far right-hand side, similar, just a different part of that air hose drop down where you've got the actual handle connected and you've got a leak there. So acoustic imaging is really just overlaying a sound profile onto a visible light image so you can see things that you can't hear with your ears. And the acoustic imager, the i900, is designed to capture sounds that we can't hear with our ears. So we hear between about 2 and 5 kilohertz. That's what the human ear can pick up on. The acoustic imager, the i900, is visualizing sounds between 2 and 52 kilohertz. So it allows you to hear the things that you can't hear with your own ears. It also allows you to hear things in a noisy environment that you would be able to hear with your ears, but you can't hear because it's so noisy. And I'll show you how you can use this technology to filter out and hone in on specific frequency ranges that you want to visualize sound within. All right, so I want to just show you this quick video. I'm just going to hit play. It doesn't have any audio here, but that's not the point. What I want you to see, this is actually Justin, by the way. So if you recognize the face, it's because it was on the intro slide. This is just to give you a feel for kind of the size of the tool, to give you a feel for the use of it. So you can see Justin here, he just turned it on. He set it to capture images, and now he's walking around and so no training needed, no headphones, no deep knowledge of how to use the tool. It's really just pick it up, turn it on, and start scanning an area. And where there could be leaks and where you see those targets appear, that's where you want to go and inspect a little bit further and try and identify and fix the leaks. This is a zoomed in view of the screen. So you turn on the i900, this is what you're going to be looking at. You're going to see menus on the left-hand side that allow you to toggle between capturing images and videos. It's going to give you access to your memory so you can capture those images and videos and go back and review them or export them to your computer. You've got the acoustic setting there on the left-hand side as well. That just allows you to fine-tune the instrument for the specific leaks that you're looking for. And then palette allows you to change the ways or the color that the sound will appear on the screen. Markers, that will allow you to turn on and off that decibel reading in the center of the screen. So you see there it says 90.3 dB. That's the sound profile or the amplitude of the sound that you're visualizing, and it's displayed there in the middle of the screen. That can be turned on and off. And then finally, in the menu options, you've got settings. That's just basic settings like time, date, language, things like that. On the right-hand side of the screen, what you see is the frequency scale. So like I had mentioned, you've got the ability with the i900 to visualize sound between 2 and 52 kilohertz. That's represented there on the scale. But you also see that yellow rectangular box and the little circles on the top and bottom there. So what you can do with that box is you can pinch that box to make it a tighter span, or you can expand that box to make it a wider span. And you can also adjust the level. So if you press and just put your finger on the touch screen and hold in the middle of that rectangle and slide your finger up and down, it will essentially allow you to eliminate the sounds happening in frequencies outside of the band that you've defined. So say, for instance, you're in a really noisy facility and you're getting a lot of noise in the 5 to 25 kilohertz range. And you know that the compressed air, compressed gas, or whatever type of leak that you're looking for is going to have a sound profile in those higher frequencies, you can adjust that band and scale it up to only visualize sound in those higher frequencies, similar to what's being done on the example here in the screen. So it allows you to not only hear things that you can't hear with your ear, but to eliminate a lot of the other sound happening in a facility. Identify so there's a view of the screen there. The primary reason that we launched the II-900 or developed the technology was because our customers told us, hey, we need a better solution for finding and identifying compressed air leaks because of the reasons that I just described. It's noisy and it's difficult for us to find them through what we would call like snake hunting, so just going around and listening for leaks. They also told us that some of the methodologies or technologies that were out there for finding leaks were just really time consuming or difficult. So customers were actually using soapy water. I know I've done this to find leaks in the past, and maybe you've done that too, where you fill a squirt bottle or a spray bottle up with soap and water, and then you can go around anywhere that you would anticipate a potential leak to be, and you can spray that area, that fitting or that connection or whatever the case may be. And where there's a leak, you've got pressure coming out, and so it causes the soapy water to bubble. And so where you see bubbles, you've got a leak, but really time consuming and difficult to do in places that are hard to reach or hard to access. And then customers were also saying, hey, we use ultrasonic leak detectors, and they work pretty good, but oftentimes we'll have to have a third party come in and do those inspections because it takes somebody that's trained and experienced in order to use the technology effectively. Or again, it's just really time consuming. Even if we have the resources in-house to do it, we can't go and scan a large area really quickly. So they asked us for a better way to do it. And the reason why our customers were focused on identifying and fixing compressed air leaks, at least primarily, was the impact that it had on their energy bills. So let me share with you just a quick case study that we did with a local company called Genie. They make the scissor lifts that you see here. One of the maintenance managers that we talked to and did some work with to help them understand and implement the technology, but also so we could learn from them how to build a tool that customers would like and customers would use and be able to implement. This is what the maintenance manager said to us. Hey, it takes almost an hour with traditional methods to find leaks up in these high and hard to reach places, and we were able to find them right away with the II-900. So just kind of a cool quote from him, and some deep appreciation from us, just helping him find a solution for his team that saved such a crazy amount of time. So that was one thing that stood out to us that was pretty cool. But here's where I think the more powerful thing is how much money Genie was able to save in a single facility by using the II-900 to identify and fix compressed air leaks. So here's a look at some of the data. So what we did before going and finding and fixing all of the air leaks was we hooked up a Fluke power logger to each of the 4 compressors that they have in their facility, the air compressors that they have in their facility. And you can see all 4 of them were running, all 4 of them were consuming energy and costing money. And then so the before graph shows the power profile before identifying and fixing any of the leaks. The after profile is a look at the energy usage after spending a few days going around with the II-900, identifying the leaks and fixing all of them. And what that translated to was almost $50,000 of annual savings on their utility bill or their electricity bill. And it also recovered almost 25% of their air capacity. And if you can see the bottom graph there, compressor number 4 it didn't have to run at all. They were able to recover so much capacity that it shut down compressor 4, and they didn't have to run that one anymore. They had now a more robust and redundant system in case of some other catastrophic failure. Justin, I think you were actually on site with Genie, helping them use this technology and doing this whole study. Anything else that you saw while you were there that you think is worth sharing here with the group?
Yeah, well, they were actually talking about another area where they wanted to put a 5th compressor. So they were going through the capital request, and they were pretty happy they didn't have to use that. that money, go get that money, because they could use compressor 4 for where they were expanding. The other thing is that this was not a maintenance team that didn't know what they were doing. They knew there was an issue, and they tried to fix these, and it just was too much work. So they just were very excited to see the solution and how easy it was to locate these.
Yeah, that's interesting. I've heard that feedback from customers before as well, that they've got a desire to do more leak detection or leak identification, but because it's so time consuming, they're just can't keep up with it. Yeah, that's interesting. All right, so here's a quick look at some of the top industries. So we've had the IA 900 kind of in the market for just over a year now, and this isn't a comprehensive list of all of the different areas or industries that are using the technology and having a pretty significant return or impact. But this is just a high level view at some of the places that we've had the most success, I guess, or our customers have had the most success really implementing the technology and using it to add considerable value. So when we get into some of the different ways other than energy savings that our customers are using the technology to add value in, you'll see some of these industries. You'll see a couple of additional industries as well. But this is just to give you a view quickly of where our customers are having some pretty significant success. And I talk to customers all the time about this technology and thermal imaging technology and just Fluke tools in general. And I asked recently some of our customers who have implemented this technology, hey, why did this make sense for you? Why did acoustic imaging make it to the top of your priority list, and why did you decide to invest? And like I was sharing earlier, and me and most of Fluke, we thought, oh, this is an energy savings thing. People want to have a more effective way to realize or recognize energy savings in their facility. We thought that's what it was all about. But what's interesting is our customers started coming back to us and saying the reason that they chose to implement this technology in their facility was actually quite different. So you see some of these examples here. One of the guys that I talked to said, hey, this is about quality control. He's using acoustic imaging to make sure that the products that they deliver to their customers are of the highest quality, or they're using the acoustic imaging technology to make sure that they don't have a quality defect that requires scrapping or batch scrapping for the product that they manufacture or produce. So for him, it was all about quality control. For others, and I think you heard this a little bit in the Genie case study, it was all about how much faster they could identify leaks versus some of the traditional methods. So it wasn't like, hey man, I want to save money on my energy bill, and that's what makes the most sense. I've got an issue I need to troubleshoot. I want to get that piece of equipment back up and running as soon as possible. And if I have to go spray each of the fittings with soapy water, or if I have to get a trained professional with an ultrasonic leak detector in to go through their process, I can't get my process or my equipment back up and running as fast as I can with a tool that allows me to scan an entire area in just a matter of seconds. So for him, it was all about the labor savings or the time to identifying the problem area. That was really the value add. And then finally, some of our customers, and this guy in particular, is saying, hey, it's my job to keep people safe. The II 900 can identify leaks as far as 165 feet away. And so there's some situations where there's rotating equipment, or there's equipment that gets extremely hot, and getting people close enough to identify a leak or pinpoint an area where there's an issue using traditional methods is just not safe. So that ability to be able to identify areas that require some more attention or require some sort of maintenance fix at a distance was the value for that customer. So with that, I want to share some of those additional ways people are using acoustic imaging to solve problems or to help them in their facilities. And so I'm gonna have Justin kind of lead this part of it, because he was actually involved in quite a few of these different customer stories, and I was involved in some, so I'll share. But this is the part where we're really going to focus on some of those applications or those ways that customers are finding value with acoustic imaging that has nothing to do with energy savings. So Justin, why don't you walk us through at least the first few here?
All right, Adam, thank you. Yeah, we have a lot of different, I think seeing the examples, a good variety of these examples will help give you an idea of where in your facility or with your situation, what's the value here. So in this case, it's a control air pressure regulator, and there's a vent port pictured. And this is really one of those troubleshooting situations where is this working properly? Are we getting, it's meant to keep internal components dry, but in a lot of situations there should be venting here on the regulator, but a closer look found that there really were 2 leaks here, and it wasn't normal operation, which is the sign of trouble, and they needed to go in and do some maintenance. So without this tool, being able to find the 2 leaks and troubleshoot that down to the root cause would have been nearly impossible, really, with other methods, and probably would have gone undetected. Yeah, so here's another one that I think is a great example because it's kind of multiple. It's not just pneumatic here, but it's the tool was able to find an issue, a root cause of an issue that they couldn't find. Customer complained that there was these electrical failures. They didn't know why. They were continuing to replace components, but really the root cause was that the compressor air dryer wasn't operating efficiently, was causing this condensation, which would then cause electrical components to fail. Being able to diagnose exactly where that was happening allowed them to determine what it really was, and that there's this, the air dryer is not working, there's condensation happening, and the water vapor stays in the line, causing this electrical component to fail. So I circled the red section there because that's corrosion. It is kind of a sign of that there was this extra water vapor in the air, but determining exactly where the issue was helpful here. Okay, I really like this example because it's a situation where the failure continued on, and so this customer was showing where there had been. This is a pressure regulator that's extremely corroded. I mean, this thing failed, and it was pretty bad. You can see that there, but in previous times with this type of equipment, they would just replace that regulator and it would fail again. So this is an example where it's in the food and beverage equipment that has a number of different types of gases compressed. But this particular line wasn't a corrosive gas. I think this was an air, but there was a leak in a different area which was starting to corrode those components. So in the end, they were able to determine with the i900 that there were small leaks in the system around that area that over time corroded the component. So instead of just replacing components, they were able to find the root cause, and the value there is huge.
Yeah, this is a really cool example, Justin, and it reminds me of another example that we don't have actually in the list to go through here today. But there's a food and beverage facility that uses CO2, like I would imagine in this case, as part of the production process for what they produce. And that was another one that was interesting to me too. Is they were getting some complaints about the beverage that they produce being flat, And so when we had our team on site helping them kind of understand and start to use the technology there, they actually spotted one of those CO2 leaks, maybe similar to what was causing the corrosion on this component here. But that was, for them, that was a really big deal, because they didn't understand the root cause behind why the carbonation level for their beverage wasn't meeting quality standards. And they were getting complaints from customers, and they were like, wow, we can find issues in our production line that are impacting product quality with this tool for CO2 leaks. So very different than what we had originally thought was going to be the way that customers would use acoustic imaging. So yeah, that food and beverage example and CO2 example definitely reminds me of some other stories as well.
Right, and then in the food and beverage, there are quite a bit of compressed gases, like for the CO2 with the additive, but also in the packaging. And so a lot of applications coming up there where finding the leaks has been helpful for our customers. This is not exactly that type, but it is in a food and beverage where there's customer was complaining of the valve actuation not working, and so the technician working on that then just increased air pressure in the whole in that whole zone, which caused other components to fail, which then further caused more issues because there was the reliability of this equipment was poor and it started to fail. So not knowing what the real issue was, they compensated, causing reduced reliability even further. And you can only guess how much value that is to increase the uptime, to reduce maintenance costs, because you're really fixing the right piece of equipment or the right leak. So I thought this was a really good example of a customer coming with an issue, not knowing where it was, and the tool helps you find that. Okay, quite a bit different type of example here. This is an air handler and all the ducting, and you can see in the pictures there's quite a few leaks going on. And this was done right away. This was done within a few days after maintenance had done their full kind of maintenance check. So being able to find those leaks and pinpoint them and investigate quickly is valuable, because these leaks are not a good thing. It can cause the damper to stick, not fully operate, and the potential for huge problems like shutdown is real. And certainly the maintenance causes more maintenance to be done, but just the value of being able to kind of see this before it becomes an issue and shuts down the plant is what they're interested in. Yeah, and this is this is one that I think you can talk to, Adam. I think you were on site on this one.
Yeah, I was on site here. So what you're looking at in this picture is some of the airlines that are all coming to a connection point on a semi truck. So this is a facility that produces semi trucks. They've got large amounts of compressed air to operate some of the different things on the truck, and as part of their production process or quality control on their production process, they would have a group of folks go around with an ultrasonic leak detector and inspect each of the different connection points for these pneumatic lines. And so it was just part of their quality assurance in their production line. And we went in with an II-900, and we were anticipating looking at exactly what the tool kind of was intended for when we launched it. So we were going to go and try and find areas to improve their energy savings capabilities. And somebody pulled me aside and they were like, "Hey, Adam, we've got a team over here that's doing an inspection on a new truck coming off of the production line right now with ultrasonic. Let's see if the II-900 can work for that team. And so we walked over and we got together, and they showed me kind of all the different areas that they inspect, and I handed the tool over to Jim, was the guy's name, and he said, okay, I'll give it a shot. And he increased the frequency range up there between 38 and 48 kilohertz, and he inspected the area. And actually, this truck had just got done being inspected by the ultrasonic leak detector, and it had passed that inspection. He went through and inspected the whole truck, and right away he found this leak on the one of the connection points there. So they actually implemented this technology as part of their production process to ensure quality for all of the trucks coming off of the production line. So a pretty cool story there, and completely unintended for the purposes that we were even anticipating and going and doing a demonstration for this customer. So
yeah, and
that's how
part of why we're bringing this up is if you can see examples, maybe it'll point you to another area that you want to inspect. Just being aware of this tool. No, they didn't know that something that was this powerful to use there. So great. This is there are these access panels on product reservoir silos, and in some cases these need to be sealed well, or there'll be issues. The i900 was able to highlight that there was a seal issue there, right on that one nut. So it was an O-ring, bad O-ring there. And why is that important? Well, it's quality control. I mean, potentially contamination can happen if the seal is poor, and depends on whether it's positive pressure here or negative, but it's a waste and safety issue. All right. Well, you've probably all seen dust collectors. It's pretty common. If there are issues in the dust collection system, they usually can't find those right away. This was an easy way to notice where there's a potential issue from the ground without much effort, and send the maintenance team in that area to investigate. So it's really a huge troubleshooting improvement, and you can kind of catch inefficient or bad operation much earlier here, and so that it can reduce your maintenance costs, of course, energy savings if this is running more effectively. All right. Well, we've all seen ductwork here. I mean, this is, and leaks. It's not supposed to be leaking, obviously, and there's good, but we know that a lot of these systems are not perfect. But ideally, they would be they sealed, and in some cases that's a big deal. In some cases, maybe that's not a big deal. But if you're venting hazardous gases, yeah, you're going to want to find that quickly. Or if you want to try to save energy by not having all that loss, this is a good place to look as well.
Yeah, I've been on site at a couple of the customers that have exhaust systems or ductwork like this to suck some of the off-gassing or some of the byproduct of their production process out of their facility. And one of the other things that I've heard IN900 being used to identify leaks, or the importance of it, is really about safety for the employees. So if any of those noxious gases or that off-gassing or byproduct if too much of that gets into the facility where their people are working, it can definitely impact their health. And so that was one of the things that really stood out to them was, hey, we've got a commitment to our people to give them a safe working environment. And so if there's a tool that can help us identify these vacuum or negative pressure leaks in our systems that are intended to keep people safe, it was absolutely worth implementing a program to do that. The other thing that a customer, or actually I can think of two situations in a similar application where there was extreme value, was if they had too much off gassing happening with their production process, it could actually create some paperwork from an EPA perspective. And so they are implementing this technology basically as a safeguard to have any EPA issues. So depending on what's rolling through that ductwork, whether it's just efficiency of the system or keeping people safe or avoiding paperwork or potential fines and regulation violations, the different kind of ways that identifying and fixing these leaks can add value is pretty vast. So a neat application with so many different kind of areas of potential value added there.
Great, yeah. And here's a place where there's a lot of potential value too that you might not think of. We're looking at an overhead conveyor system, and so there's bearings, and in this case pneumatic controls as well. How do you do your maintenance? How do you do it efficiently? If there's an issue, where is it? How do I detect that? And in this case, what we're looking at is actually noise from the bearing, but it could be a pneumatic leak as well. Being able to pinpoint that from the ground quickly can reduce your time and money in really getting up there and fixing it, bringing the right tools, even whether you're going to build scaffolding in a certain area or not. And so there can be a lot of money spent on scaffolding. I mean, some places use millions of dollars just for scaffolding, and it's kind of a value you might not think of right away. I don't know if Adam, you know this one as well. If you have any other comments on this one.
Yeah, this customer in particular had an annual scaffolding bill of $4 million, and so they would have scaffolding erected to just do general maintenance or checks on different areas of their system. So they would erect scaffolding, send somebody up there to just do a check, just to make sure everything was functioning properly. And so they were telling us, hey, if we can just have people on the ground scanning areas that we would otherwise have to build scaffolding and physically go up and inspect just to see that everything's okay. If we could eliminate the need to do that, that would be fantastic. And so they really appreciated that and found the tool useful in that way. The other thing that they said happens quite a bit is that they would build scaffolding in the wrong place. So they could hear a bearing squeaking, or they could hear something leaking up overhead in these conveyor systems, and they would build the scaffolding, send somebody up there, and then realize the area that they needed to address to fix the issue was just out of reach. So send the person back down the scaffolding, deconstruct it, reconstruct it in another area, and all of that was just costing a lot of time and money. So being able to really pinpoint the location that needs maintenance from the ground was a huge savings for them on their scaffolding spend, which was pretty interesting. You've got a $4 million spend for scaffolding. If you can shave a little bit off of that, it can have a pretty significant impact.
Well, and I haven't talked about it much here, where really this is a loud environment. If you're back on the overhead roller bearings, and in all of these situations, you're in a factory and it's loud. But this is loud here, and all the extra sound is eliminated through the algorithm that Fluke has on this device. Yes, you can adjust that frequency, but it's going to eliminate a lot of the background noise, sometimes all of it, like here, even when it's very loud. And
yeah, Justin, that's a good point. And yeah, you can actually see that happening on the screen. So you see the sound profile represented by the orange lines. So you see the amplitude of sound within a given frequency range. So you see down there between 2 and 20, or even all the way up to 25 kilohertz, you've got a pretty significant sound profile there. That really is kind of demonstrating what Justin just said about how loud it is in these environments. And then you've got the yellow bar, which is the range of frequencies that you're visualizing sound within, isolated to that 30 to about 45 kilohertz range, where the leak is happening, or the most sound from this leak is happening, and it allows you to just eliminate all of that noise below. But yeah, that rings true here, Justin. You can see how loud it is there from the sound profile on the tool.
And it's very surprising when you pick up the tool the first time that it does eliminate all that background noise.
Here's another one where I was involved in, can kind of help unpack the story here. So
yeah.
This is a pick and place robot. These types of robots, or this type of automation, looks a lot different depending on the process, or depending on the industry. But this is a pretty large scale pick and place robot, and essentially what you've got there is a robotic arm that moves around, and then the head drops down onto a particular component, and then it uses suction or vacuums to pick something up, move it to another part of the production line or the production process, and set it back down. And there's a lot of different vacuums, or compressed air, or vacuum connections. And so what our customers would tell us is like, hey, we've got an issue on this robot, on this pick and place robot, but we don't know exactly what. It's dropping components, or it's moving them to slightly the wrong place, and we don't necessarily know why. And they would have to shut these things down and try and figure out a way to troubleshoot and identify exactly where the problem was coming from. Or if it was just having a suction issue, they would shut it down and they would replace all of the different cups, which in some cases is a lot and pretty expensive, just to make sure that they address the issue. They were able to use acoustic imaging technology to not only do the troubleshooting while the unit was running, which just made it a lot easier, but also they were able to pinpoint the exact location where the issue was happening, so they didn't have to do like a complete overhaul or a complete retrofit on the piece of equipment just to hopefully address the issue. So this was a value add for a couple of different reasons. Not energy savings, it was troubleshooting quickly, and it was also reducing the cost of the fix, because you weren't just throwing money at it hoping that you were finding and fixing the issue. It was extremely apparent where the problem was, and you could go in and fix the particular part that was going to address root cause. So this is a large scale.
Being able to verify that fix, Adam, is really helpful too. And our customers say, "Oh yeah, I can just bring that back," and when it's truly been fixed, that sound is gone. Sometimes it wasn't fixed properly yet, but you can just see that in an instant.
Yeah, good point. We don't have the picture on here that shows the component with no acoustic profile. So that's ultimately what you want to see. But maybe we should add that so you can see the verification piece.
Yeah,
I hear that all the time.
And giving that to the person that needs to know that is also nice.
Yeah, good point. Good point.
Yep. Okay, control air regulator and valve operation is pretty critical in a lot of places, but it's hard to troubleshoot this. So here's an example where also knowing exactly where pinpointing that leak and can help you determine what the real issue is. It's not just, well, there's a blob in some area. You can kind of move around, get closer, and determine really what joint is leaking. And this is looking at an argon tank outdoors, and it's obviously a leak. And without this tool, you might not find this, maybe for a long time, and it's just blowing out money because argon is expensive.
Yeah, I've been on site to several locations that have outdoor storage tanks for argon or helium or nitrogen or a bunch of different types of gases that are used in part of a production process or for a particular industry or facility. And so I see these storage tanks quite often. Large truck drives up, they fill up the tank, and then all of that gas is then piped into the facility to support some part of the production process. And this one is interesting because this is all kind of like the direct costs that can be addressed by using acoustic imaging. So it's not indirect costs like an energy savings thing. It's all about kind of hard top line dollars that are being spent for a production process. So argon is extremely expensive. Some of the other gases not as bad, but still, if you're just leaking part of the gas needed for your production process straight out into the atmosphere, that's just money rolling out your piping. And so in this particular case, this was actually just 2 of 4 leaks that we found from the tank to where the gas is actually put into the production process. So there was another leak at another 90, right where it went into the facility and then bent to go to the area of the facility that was being used. And then there was another leak right where it went into the production process. So they had stepped down the pipe size. It wasn't like this, 2-inch pipe that you see here or inch pipe that you see here. It was stepped down quite a bit, so the leak was a bit smaller. But still, if you add all of those 4 areas up, it turned out to be a pretty significant dollar amount when we quantified and annualized the cost from these 4 leaks.
Right. And so we have that material cost, we've talked about quality cost, we've talked about maintenance, uptime, and this is a little bit different example where it's a rail yard station. The trains pull up here and then the tubes suck out all the product. But what if it's not operating effectively? There's some leaks going on here, so the pressure is not as good. Well, it's going to slow down the speed here and increase time to unload. So it's a bit of a hidden cost that so the value in fixing this could be turned into dollars. And steam leaks are pretty common. We know it costs money to produce steam, and a lot of places just live with leaks. They're too far away, hard to identify. I think this photo was taken from well, over 100 feet, and pinpoints for the maintenance team where to look. And you might not even really attempt to fix this if you weren't able to quickly scan and find. So it's a value you might not think of.
Yeah, I see a lot of these steam traps and steam lines that are way up overhead, difficult to access. There's other technologies that you can use to identify steam leaks, but when they get in hard to access places, I think that's where our customers are really telling us that this technology can help. So
Great.
that is what our customers are telling us about ways other than energy savings that they're using the technology to add value. Hopefully that got your wheels turning a little bit on how you could use the technology in your particular applications or to add value in your industry or your facility. It looks like we've got about 10 minutes left. So Dustin, if you wouldn't mind just reading some of the questions that have rolled in the chat, and Justin and I will hang on here and get those questions answered.
Yeah, Adam and Justin, I haven't seen any questions pop through, so hopefully, if anybody out there has questions, we'll hang on for a few minutes here and let you get those in.
Yeah, would love to answer the questions, about, any concerns that you have or questions you have about a specific application, or if there's something that you want us to go a little bit deeper on, or add some clarity or color on from something that we've gone through. Um, Again, this is intended to help you and help make sure that you leave here with a better understanding for the technology and how it can be used. So we'll hang out and get those questions rolling in, and Justin and I will get you some answers. All right. Well, it sounds like there's no brave souls, or maybe we were just comprehensive and got all your questions answered. Either way, we will follow up with you if you do have any questions moving forward, and definitely appreciate you joining today and learning a little bit more about the technology and how our customers are using it. So unless you've got anything else, Dustin, I'll
Yeah,
sign off.
we got something flowing here.
Oh, here we go.
Well, somebody asked, was this intended to be the exact same presentation as last week, even though they have different titles?
Yeah, so that was intentional. What we were focusing on last week was the specific application spaces. This week was intended to communicate more about the value that is derived from using the technology in those applications. So yes, it was intentional. Just trying to add a little bit more context around the value that different application spaces add, as opposed to the different applications specifically, and how to use the technology to find leaks in those applications.
Well, I think it's important to note that the next webinar will not be as similar. If you're interested in that next webinar, a little bit more difference.
Can we, are we able to get a copy of this to give to our sales team? This presentation?
Yeah, absolutely. We'll make the content available to help people understand and customers understand the different ways that the technology is being used. If you want to connect with that person separately, we can figure out how specifically to get it to whoever asked that question, Dustin.
Yes. John Dines asked if you can go over how the info is moved from the II-900 to other devices.
Yeah, absolutely. There's so John, there's a USB port, a mini USB port in the bottom of the tool. So when you capture images or you capture videos, they get stored to the internal memory on the II-900. And then what you do is you just plug in that USB cable from the tool into your PC, and then it shows up as a device on your computer, and you can just select to download all of the images. So this tool comes with what's called Fluke Connect desktop software, and you can use that software to import all of your images or videos into and build reports. Typically, we see customers using those reports either to communicate to whoever's going to be doing the fixes on the leaks identified, so they have record of where to go and what needs to be addressed, what specific component or area of the facility needs to be addressed, or for some folks, they're providing this as a service, so using the reporting functionality to essentially hand their customer a report of all of the issues or areas of opportunity found.
And then Mike Bicker had a question, but we'll take that one offline. All right. I think that about does it.
All right. Well, thanks, guys. Thanks, Dustin. I appreciate it.
Yep. Thank you, guys.
right.
Thank you, everybody, for joining. Hopefully you enjoyed the rest of your day and getting prepared for the weekend. Stay tuned next week. We will have another presentation around the II900. So visit fluke.com to go ahead and register for that, or watch out for the postings on our social media platforms. If you're not following Fluke on LinkedIn, Facebook, Twitter, Instagram, please do so. A lot of great information being put out there, and um, really good stuff. So look forward to seeing you guys next week.